Hello friends, welcome to my channel. Today we are going to focus on analysis of overhang beam manually and using Etabs software. We are going to calculate shear force, bending moment and draw shear force diagram and bending moment diagram for the overhang beam. Here in this overhang beam, BD portion is overhanging, acting as a cantilever. Support A is hinged and support B is roller. 5 kN per meter uniformly distributed load is acting in the span AB and 20 kN load is acting at the mid of span BD. The total length of the beam is 16 meter, and using equilibrium equation summation fx equals 0, summation fy equals 0, summation moment equals 0, we find reactions and moment at supports. Now for reaction at A, let us consider the reaction at A is acting upward. Then we have summation moment at B equals 0 since B is roller support. Now A times 8 meter, distance 8, 5 kN per meter load acting in downward direction minus 5 into uniformly distributed in 8 meter, so 5 times 8, and the center of gravity of UVL is rectangular shape, so 8 by 2 from support B. Then as since support A reaction gives us a clockwise moment and 5 kN per meter gives us anti-clockwise moment, the symbol is negative, and for 20 kN load the moment it gives is clockwise, so plus 20 into distance from B 4 meter, 4 equals 0, which gives us A is equal to 10 kN. Now using summation f y equals 0 in y direction, we have reaction at support A plus reaction at support B equals 5 kN per meter acting in downward direction, so 5 times 8 total length plus 20 kN gives us 5 times 8 40 plus 20 60. Since A is 10 kN as we have already calculated it, which gives us B equals 50 kN acting upward both. Now let us make shear force diagram. Support A gives us reaction 10 kN, so we have 10 kN load, 10 kN in downward 10. Then it goes 5 kN per meter UDL, so we have 10 minus 5 times 8, which gives us 10 minus 40, which gives us 30 kN in negative, so the shear force changes direction. Since UDL load is present, the inclined shear force diagram is made to support B. We have 30. Then the support reaction at B is 50 kN in upward direction, which gives us 30 minus 50 20, so shear force again changes direction to negative 20, negative no positive. Then it goes linearly to point load at support C 20 and 20 kN load acting in downward the shear force finally to 0. So this is shear force diagram and support, let it name A, B, C and D. Now for bending moment diagram. For span AB, bending moment is in support A, reaction is 10 kilonewton, so we have bending moment in support AB. AB is 10 times of x for distance x minus 5 in downward direction, so minus 5 times x times x by 2 for rectangular center of gravity, which gives us bending moment in span AB 10x minus 2.5 x square. So for x is equal to 1, we have bending moment 7.5, for 2 10, and again goes to 7.5 for 3, then goes to 0 at x is equal to 4. Then for x is equal to 8, we have bending moment at support B is 80, positive 80. So bending moment changes direction from negative to positive, and bending moment diagram is curve. And the 20 kilonewton load at C in overhang section gives us 20 times 4, 80 kilonewton meter moment. So 0 to 80. So this is our bending moment diagram. Here you can see the shear force diagram and bending moment diagram clearly with values. Now we will use Etabs to do this problem easily and fast. Open Etabs, new built-in setting metric, Indian system. Okay. Here grid lines in x direction for support A, support B, and D. So 3 grid lines in x direction, no grid lines in y direction, so 1. Number of stories mean the z direction number of grid lines. We have 1 number, so 1. Spacing we will change, we will modify grid 1. Okay. Now since 8 meter is already as in our question, 8 meter, so we will now define material. A new material, India Steel Fe250 grade we define. Okay, define section properties, frame section. We delete this, later it will create confusion. So take ISLB 600, modify Fe250. Okay. Now we will draw beam ISLB 600 from A to D. Now we have support A is hinged and support B is roller, and no supports in overhang section, so we assign joints. Joints in support A is hinged, so this strength hinged apply, and in B we apply roller, apply. Here you can see hinge support in A and roller support in B. Now we will assign load. Assign frame loads, point load in section C is 20 kilonewton acting downward. So we assign live load in gravity direction at mid of the section, so relative distance mid 0.5, 20 kilonewton apply. Now for this AB beam we have 5 kilonewton per meter uniformly distributed load, so we assign frame load, distributed load, live load 5 kilonewton per meter UDL, apply. Okay, you can see 5 kilonewton load per meter load here. Right click it, you can see 5 kilonewton per meter load acting in span AB and 20 kilonewton at 4 meter in span BD. Okay, now we will run it. Close this window. We will see in 3D. Run the program. Save it D2. save. The program is run. We will see the reaction in Z direction. Apply. Okay. This load is due to dead load, but we are dealing with live load, so here we set the dead to live. Apply. Okay, see 50 kilonewton and 10 kilonewton load acting at support B and support A respectively, as we have calculated 10 kilonewton and 50 kilonewton. Now we will see the shear force diagram. So the values, apply. Okay, here you can see the shear force is same as we have drawn, minus 10 to 30 to minus 20 to 0 in C, minus 10 in A to 30 in B, which reduces to minus 20 and finally goes to 0 in C. And the CD section has no shear force as we have calculated. Now we will see the bending moment diagram. For this, click it, moment 33 as in perpendicular direction to load. Apply. Okay, same 10, here you can see 10 and it goes to minus 80 as we have drawn it, from minus 10 to 80, minus 10 to 80. If you want to learn Etabs, you may go to channel shown in screen. Don't forget to subscribe the channel and press bell icon for further notification. Thank you.